Hello friends, welcome back to my channel. Today I will start electron transport chain. Complex 1. In this complex NADH H plus present. It is oxidized by NADH dehydrogenase. It comprises an enzyme consisting of iron, sulfur and FMN. FMN is derived from vitamin B2. After oxidized, 2H plus released and 2E transport to FMN. After then transported to FES from NADH. Mainly the ubiquinone is a mobile carrier which is localized inner membrane of mitochondrial. Ubiquinone is mobile carrier. It helps to maintain electron transport from complex 1 to complex 2. So electron transport to ubiquinone. Other side H plus ion comes from inner mitochondrial matrix because H plus gradient presence in the matrix. H plus conducts with ubiquinone, converted ubiquinone H2 is reduced. So that is a function of complex 1. That next complex 2. Complex 2, that is the similarly for the complex 1. Complex 2 succinate dehydrogenase another electron carriers and coenzyme. Succinate is oxidized into fumarate, causing FAD, flavin adenine dinucleotide, to be reduced to FADH2. The transport molecule FADH2 is then deoxidized, donating electron. Ubiquinone and H plus ion condense similar to complex 1 but complex 2 present FAN. Complex 3. The third complex is composed of FES protein, cytochrome BC1 and cytochrome C protein. Cytochrome protein consists of the heme group. Cytochrome C is reductases. Where the Q cycle takes place in this complex 3. There is an interactions between Q and cytochromes, which are molecules composed of iron to continue the transfer of electron. During the Q cycle, the reduced ubiquinone QH2 previously produced denotes electrons to IsP and cytochrome B becoming ubiquinone to IsP and cytochrome B becoming ubiquinone, and cytochrome B are proteins that are located in the mitochondrial matrix. The fourth complex is comprised of cytochrome C, A and A3. So the electrons are transferred to cytochrome A, after then cytochrome A3. The electrons, in addition to hydrogen and oxygen, then react from the water ions, irreversible reactions. This is the last complex. The transcolate 4 protons across the membrane to create protein gradient that develops ATP at the end. In this complex, 2H plus half 1 by 2O2 plus 2 electron minus consist of H2. In this reaction's product of H2O released. Next, complex 5. So naturally, H plus pumping complex 1, complex 2, complex 3, complex 4. For these reasons, H plus of the high becomes high concentrations of the mitochondrial inner membrane phase. For this reason, H plus ion across from the mitochondrial membrane to the outer membrane phase. This H plus ion, the proton gradient ion, are brought back into the mitochondrial matrix, helps to ATP synthase protein, it allowing ADP to binding to free phosphate to produce ATP. So complex 5, F1 and F0 ATP synthase, sometimes referred to as complex 5, generates as the ATP.